First, we're going to take a look at this diagram here, which explains a lot. Consider a function f of x being traced out by this orange curve. Consider a point P that lies on that curve. So this point P is right where my cursor is. We can draw a tangent line to the curve at point P. Now, that tangent line, or the gradient of that tangent line, will be exactly equal to the gradient of the curve at that point P. So the steepness of this tangent line will be exactly equal to the steepness of the curve at point P. And this is a tangent line, and we can find an equation for that, and it'll be in the format y equals mx plus c. Because it's a linear graph, or a linear equation. We can also have a normal line. Now, the normal line runs perpendicular to the tangent line. So that just means at right angles with, and you can see that right angle drawn here. Again, this is a straight line, and it can be in the format of y equals mx plus c as well. Obviously different m's and different c's, but it's just a linear graph. Alright, a known fact. When we multiply the gradient of a tangent line by the gradient of a normal line, the result is -1. And we'll use this little fact to help us when we do various problems. It comes up all the time. Okay, let's look at all that information in practice. Problem 3. Find the equation of the tangent at a point on the curve, f of x equals 2x squared plus 5x plus 6, where the gradient is equal to 7. Okay, so what we've got here is a function f of x. We need to work out where the gradient of this function is equal to 7. So we need to find out an x and y value for that. And from that, we'll be able to find the equation of the tangent line at that point. So we begin, you state what f of x is. We work out its derivative using the normal derivative rules. We then make the derivative equal to 7 because we're interested in finding where the gradient is equal to 7. We solve for x, and obviously we work out that x is equal to 1/2. So that's only part of the point, so that's the x value. To work out the corresponding y value, we need to substitute it back into the original function. So I'm going to take f of 1/2. So we don't substitute it into the derivative, we substitute it back into the original function. If we do that, you can see we get a value of 9. So the point that we've tried to work out is 1/2, 9. So at that point, on the curve f of x, the gradient will be equal to 7. We're required to find the equation of the tangent line at this point. The equation of the tangent line comes in the form y equals mx plus c. The gradient I know is 7, so I substitute that in. That's from the original part of the question. I now substitute in a known point. A point that I know is on that tangent line is 1/2, 9. So I substitute that in with an unknown c to be found. I work out c as being 11/2, and therefore I can state the equation of the tangent line. Y equals 7x plus 11/2. So the gradient is 7, and it cuts through the y-axis at 11/2. Let's now consider part B of the question. Hence, so in other words, we use the information that we've already found. Find the equation to the normal line at this point. So we have to find the equation of the normal line. I use the fact that when I take the gradient of the tangent line and multiply it by the gradient of the normal line, the result is -1. And you can so end up finding that the gradient of the normal line is -1/7. Again, the normal line can be represented in the format y equals mx plus c. I substitute the gradient in, which I've just worked out from above, so the gradient is equal to -1/7. I now substitute a known point that lies on that normal line, and I'm going to be using 1/2, 9, which I've done here, and you can see that I get a result of c equaling 9 and 1/14, or if you like, 127/14. And now I can just simply state the equation of that tangent line. So y equals negative 1/7 times x plus 127 on 14. So this is the technique that you would follow if you were to do this by hand, but sometimes you are allowed to use your CAS calculator. So how do we do it then? Okay, so looking at using our CAS calculator to find the normal line and the tangent line. So I need to go to Menu, Calculus, and then I'm going to go down to Tangent Line. I'm going to put in the right-hand side of the f of x equation. So I'm going to be putting in 2 times x to the power of 2 plus 5 times x plus 6. I'm now going to tell the CAS calculator that I'm interested in the tangent line for a certain value of x. So I'm going to put in x, comma, and then I'm going to state the x value where I want the tangent line to be calculated from. So I'm going to put in a half. Notice that I'm putting in a half written in fractional form rather than 0.5 because I want the CAS calculator to provide me an equation in fractional form, which is more exact, obviously, than providing decimal approximations. So I hit enter and I end up with the tangent line, and that represents y equaling 7x plus 11 on 2, which is exactly the same result as if I had done it with pen and paper. Now let's see the normal line, same kind of process. So CAS, and this time I want the normal line. And I'm going to put in the equation again, 2 times x to the power of 2. Of course, I could always define the function if I was doing numerous calculations with it. And again, involving x, and again, the half. Hit enter, and you can see I get that result there. Of course, I could rewrite this as being y equals negative x on 7 plus 127 on 14. So it's in that exact same format of y equals mx plus c. Obviously, using your CAS calculator is going to be a lot quicker, little chance of making an error, but you do need to know the technique by hand as well.